So the next 2 pages of notes are just calculator instructions for what we've already learned how to do. So I have tech videos, and you're welcome to go look at those and see how I make exponential models in both the calculator and Excel. You're going to need them for projects that are coming up. Let's do the last problem. So we're supposed to create a scatter diagram of the data with a calculator and draw a sketch. Explain why a linear or exponential model is more appropriate for the data set. And if a linear model is more appropriate, explain M and B again. Or if an exponential model is more appropriate, explain A and B. So we have data set number 1 here. This is the number of trout sold, farm-raised trout, in the U.S. at 2 years after 1990. All right, so let's put this into the calculator, shall we? Now remember, we don't really want the year like we have here. What we want is T. So since it's years after 1990, this would be 1, 3, 5, 7, 9, 11, 13, 17, 19, and 20. So that's what we're going to type into the lovely calculator. Hold on, that's just driving me crazy. Okay, so let me grab it. Stat, edit, go up and clear out the old, and type in the new. Right, so 1, 3, 5, 7, 9. Okay, that's in. And now we're going to go over here and type in these other numbers, 67.7 and so on. I'm going to pause the video and fill all those in. You do the same. There they are. All right, now we're supposed to do a scattergram. It's been a while since we've done a scatter plot, so let's remind ourselves how to do that. First of all, you go to y equals and you clear out your old equations in there. And then you go up to plot 1 and you press enter. All right, then if we pressed graph now, it'd be kind of useless, right? It's graphing, but we can't see what it's doing at all. So what we want to do is zoom, and now down at the bottom you see it on my calculator. You might have to scroll down to see it for yours, but it's number 9. You want zoom stat, because you put the data in stat, right? And you want stat plot. So zoom stat will set up a perfect window for it. And there you go. That's what it looks like. And if you're interested in the scale, let's say you have to write the scale down for your instructor. So you can press window and you can kind of see. Oh, it was about -1. It was about 22. I'm just rounding here. It's about 33 for the Y min, or 34, and then 73 for the Y max. Okay. So I'm going to take a picture of that. And we'll copy and paste that in, because I have that advantage. You will have to be drawing that sketch by hand. So enjoy. Right, so you draw a sketch of it by hand. And again, if you're going to do it by hand, make sure you put in your scale. Tell the instructor what your X min, your X max, your Y min, and your Y max were. Now, this is not a curve, right? This is not exponential. It's more plummeting downwards, but it's kind of all over the place because real life data doesn't work perfectly linearly, right? But it's definitely not arching, right? You're not seeing that exponential curve arch. So this is linear because the points do not form a curve. Beautiful. So now we have to find it. Find that linear curve, or excuse me, that linear line. Well, we learned how to do that back in chapter 2. So we're going to go stat, calculate, pick number 4, which is linear regression, enter, and then go down to calculate and press enter. And there it is. -1.599 and 67.517, excuse me. So let me grab that. It'll help me when I type. I don't really want it, but all right. So it's trout sold. What was the, oh, they didn't give us the thing. They just want the, they gave us T. So trout, here, f of T is equal to, and we said it was linear, so it's -1.1599 would round to 60, right? 16 T plus 67.52. That works. All right, so it's linear. We found it. It's right here. Put it in a box. Now we have to explain m and we have to explain b. So m is equal to negative 1.16 and b is equal to 67.52. Actually, I'm going to do those in reverse because b is easier to explain. So b equals 67.52. All right, so b equals 67.52. What does that mean? That means that, here, let me put a colon on that. Remember, b is your y-intercept for a linear function, right? So this is saying at time 0, which would be in 1990. So in 1990, the number of farm-raised trout sold in the U.S. was 67.52 million. 67.52 fish. That's it. 67 fish. That would not work well. So it's 67.52 million. Okay, so now we need to explain m, the more difficult one. And that's your rate of increase. So every year, what's happening to farm-raised trout? Oh my goodness. Can't type. All right, every year, the number of farm-raised trout. Yes, you have to write all this all the time. You have to make a full sentence out of it with a verb and everything, right? You have to explain the situation. So the number of farm-raised trout sold in the U.S. is decreasing, going down because m is negative by 1.16 million. All right, beautiful. We're done with that one. Now let's move on to the next one. This is the number of children per every 1,000 that have been diagnosed with autism and in the U.S. at T years after 1970. I don't know why that came out that way. All right. So we are going to have to change this, first of all, to T from the year. All right. So T is our year since 1970, right? So this would be 5, 15, 25, 30, 32, 34, 36, 38. Right there. So that's what's going to go in our calculator. So if we grab the calculator, I'm going to go Stat, Edit, go up and clear out all that data we just typed in. Oh, it's heartbreaking to see it go, but get rid of it. 5, 15, 25, 30, 32, 34, 36, 38. And then go over and start typing all the values. So 0.2, 0.4, 2. And there we go. Enter. All right, so now we want to do another plot. So I have scatter plot on still, so it's still going to do a scatter plot, excuse me. But if I press graph, it's the old window from the last problem, which is no good to me. So I'm going to do zoom and press 9. And it'll make a zoom stat. Perfect. And again, if you want to see the window in order to be able to give your instructor scale, you press window and you can see I went from about, oh, I don't know, about 2 to 41 or so, negative 2 or negative 1.6 technically, to about 13, right? And you would just write that down. All right, so let me see here. There it is. I'm going to copy. Then I am going to go paste it in because I am fortunate like that. All right, so this is exponential, right? You can see it because the points are forming that kind of arch shape. So exponential model would be better because the points form a curve, arch, whatever. All right, so then we're going to have to find it. So let's grab the calculator again. Stat, calculate. And it's actually number 0. I could just press 0, but to prove it to you, here it is, right here. You can always check if you've picked the right one because it should say EXPREG at the top if you have the TI-84 calculators. 83 is not so much. All right, so L1, L2, go down to calculate. And again, if you have any desire to store the equation, you're welcome to by pressing variables, y variables, 1, 1, but is not required. In fact, in this problem, there's no point because we're not doing anything more with this. So it's 0.082 and 1.143. So let me write that up. Here, a of t equals 0.08, I think it was 0.082 times 1.14, what was that? 1.143 to the t. Okay, so now we have to explain both of those. So we'll start with a is 0.082. That's pretty easy to explain. So I think it was 0.082. Yep, it was. Okay. That is our starting amount, right? Because it's our y-intercept for an exponential model like this. So we'd say in 1970, the autism rate in the U.S., here, let's put it this way, the number of children per every 1,000 diagnosed with autism was 0.082, which is very, very small. Think about what you're saying. Saying you have 0.08 kids in 1,000. So to really actually see children with autism, you'd have to start talking about 1,000,000 children or something like that. All right, then we have the base, which is b equals 1.143. Okay. Now remember, to explain your base, you're going to have to change it to a percentage. So let me change this. This is 114.3%. Either one of those is acceptable. So you can see the extra, hopefully, but let me just write it down. 114.3, take away 100 would be, oops, percent. I'll put percent symbols in there so you don't get lost, which is 14.3% extra. That's what matters to you. So every year, the number of children with autism or diagnosed with autism per every 1,000 is increasing by 14.3%. Yes, you have to explain it all out. This is, you're explaining what in English what mathematically is going on, and you have to be precise about your language. You have to talk about every year because that's your independent variable. You have to explain what your full dependent variable is, which is the number of children diagnosed with autism and so on. And then you have to say the amount you're increasing by. So it has to be a full sentence every time. All of these things do. All right, we're done with section 4.5, which means we are done with chapter 4. I'll see you back here for chapter 5, which will be inverse functions and logarithms.